Hello. So let's discuss a different method for doing these problems. And I know some students prefer like one method, some students prefer a different method. So let's talk about a different method for doing this. So just like, in the previous examples, we're looking for a composite function. So we're looking for an inside function and an outside function. And then we're looking for the derivative of that inside function multiplied somewhere else in the problem. And so that indicates to us that we need to do U-substitution. And yeah, so that's what we're looking for. And one way to do that is we can kind of pull out any constants. So one thing that we can do is we can kind of just start with pulling out the 5. So we can say that this is going to be 5 times the integral of x times sine of x squared dx. And the advantage of pulling out all the constants is that it kind of sidesteps the issue that we saw, or like what we had to deal with in the last example, where we had to think about how to change the derivative of x squared, which is 2x, into a 5x. And so let's see this. So we can pull out a 5. So that's going to be x times sine of x squared dx. And then again, just like previously, we're going to identify, the inside function, which is going to be this x squared. And so let's do that. So u is still going to be x squared. So that's our inside function. And then just like previous, du is equal to 2x dx. And in our new integral, we don't have a 2x dx, we just have an x dx. And so what we can do is we can solve for what we have in the integral. So we have in the integral x dx instead of 2x dx. And so we can just divide both sides of this equation down here, by 2. So we're going to get du divided by 2 is equal to x times dx. And so then let's put that in. Let's first rewrite this. So this is 5 times the integral sine of x squared x dx. And so then this, this x squared, that's going to be u. This x dx, that's du divided by 2. And so then this integral is going to become 5 times the integral of sine of u times du divided by 2. And then just like previously, we're going to pull out all constants, just like we saw in the previous example. So this is going to be 5 over 2, the integral sine of u du. And then as we can see, this is exactly the same thing that we got, when we did method 1, when we did this example the first time around. And so let's finish this out. So this is going to be 5 over 2 times, the antiderivative of sine, which is negative cosine. So this is going to be times negative cosine of u plus c. And then we can multiply through and plug in our u. So this is going to be negative 5 over 2 cosine of x squared plus c.